Syzygy, episode 14, Total Eclipse of the Moon. And welcome back for another edition of the Syzygy podcast, everyone's favourite astronomical podcast. Joining me at the microphone, as ever, Emily Brunston. Hi, Emily.
Hello, hello.
So this week we're going to talk about a lunar eclipse. Interesting things, a total lunar eclipse coming up at the end of this week. But before we get into that, there are just a couple of things that I wanted to talk about involving Mars. Interesting things happening on Mars at the moment. There's a huge storm.
Huge dust storm going on. Yeah, the whole planet is engulfed.
Yeah, I mean, when we say huge, like the whole planet, absolutely massive. There's a picture that's been doing the rounds on social media over the last day or so. If you haven't seen it, go and check it out. It shouldn't be too hard to find, which shows the storm quite early on in its stages of formation. And on one side of the picture, you can see the normal Martian landscape. And on the other side, it's just blanked out dust storm. And right down the middle of the picture, there is the storm front. And it's just quite this awesome thing. But it's taken over the entire planet, including, of course, the bits of the planet where our brave little Martian rovers are.
Yeah, poor little rovers.
Which can't be good. I mean, these things are solar-powered and made of electronics. Yeah. And dust storms, not good for those. Do we know anything about how they're going?
Yeah, so they shut down during these periods, and just sort of go into a bit of a sleep mode. But I guess every shutdown is always a risk when you're talking about things like rovers. So we'll be hoping that they're going to come back on when the dust storm subsides.
I mean, I guess the question will come as to when they power back up. Is that successful or not? And are they just completely blanketed in huge, thick layers of dust? Can it work?
But interestingly, this is why we thought that the rovers, for example, Spirit and Opportunity, weren't going to last very long, and they totally blitzed that. So
they've gone
that
years
tough little
longer.
things. I think they'll be all right.
Well, fingers crossed. But I mean, the storm's still going, and it's been going for weeks now. I mean, as I guess, a planet-wide storm might be expected to do. But who knows how long it'll last. So fingers crossed for those little rovers. And speaking of rovers, we talked a while ago about the next generation of exploration out to the red planet. And the ESA has its ExoMars missions. ExoMars, which is very exciting. And it's a very good name. But they're looking for an even better name. There's a competition going at the moment for naming their next generation Mars rover, which is going to be driving around in the sort of 2020s and beyond, all going well. And they're looking for a name for it. So if you live, now the rules are, if you live in one of the countries which is covered by the ESA, so I don't know which countries those would be. I just know that Australia is not one of them. But presumably, at least at this stage, the UK still is. So listeners in the UK and Europe broadly can get involved in this competition. And I should also point out that if you're just dusting off any combination or permutation of Spacey McSpaceface, Marsy McMarsface, Rover McRoveryface, there is going to be a panel choosing from the finalists here. So it's not just going to be which one gets the most votes.
We've definitely learned our lesson on that one.
Yeah, slowly but surely. So yeah, if you're interested, get your votes in on that one. Just do a Google search for ExoMars rover competition and I'm sure it'll come up. We'll put a link in the show notes as well. Anyway, leaving behind little robot things driving around on the surface of Mars and getting involved in dust storms. Interesting thing coming up in just a few days' time from recording. So by the time we get this one out to the masses, it'll probably be that day. This podcast normally drops on a Friday.
Tonight.
And it's going to be on Friday.
Yeah.
Isn't it?
Exciting.
So as you're listening to this, if you get it hot off the presses, then get outside and have a look because it's going to be a lunar eclipse, which is very exciting. Now, unfortunately, it's not going to be at its most visible for those of us here in Europe and for a lot of the Northern Hemisphere from sort of Europe across to Northern America. But it is going to be very visible for large swathes of other parts of the world. So if you're in sort of the Middle East, Africa, and across Asia, then you're getting a good view of this lunar eclipse. So let's back up a little bit. Emily, what's a lunar eclipse?
So it's actually, and wait for it, it's actually a syzygy.
Hey!
Yay!
This had to happen. It only took 14 episodes, and we were talking about a proper actual syzygy.
This is a real syzygy. So a syzygy is an alignment of 3 or more objects in a kind of a line. And in this alignment, you've got the sun, and then the earth, and then the moon.
Right. So in this case, it's the earth that's eclipsing the moon and the sun. The earth's getting in between the moon and the sun.
Yeah.
As opposed to a solar eclipse where the moon gets in the way of the sun from us viewing on Earth.
Yes.
Yeah.
Yeah. So basically the moon's going to walk into the Earth's shadow.
Right. And so what does that do? I mean, we know that with a solar eclipse, that's a pretty spectacular event. The world goes dark, and you can view very carefully through the appropriate equipment all sorts of amazing features of the sun as it gets blotted out by the moon. But in this case, it's not quite the same, is it? It's a bit different.
Yeah. So the major difference between a solar eclipse and a lunar eclipse, if we think about shadows, so the moon casts a very, very tiny shadow onto the surface of the Earth, and it's a complete shadow. So the moon doesn't have any atmosphere or anything like that interrupts with the shadow.
So it's a very clean shadow is what you're saying.
It's like a sort of really dark, complete, little, but very, very tiny on the surface of the Earth.
And tiny because, I mean, in comparison to the Earth, the moon is actually really quite small, and it is a very long way away from the Earth, further than you think.
Yeah. And actually, the whole reason that we have solar eclipses is a complete coincidence. There's absolutely no reason for the sun and the moon to be exactly the same size in our sky.
It is staggering, isn't it? And they are the same to an incredible degree of accuracy. I mean, you also have to take into account the fact that the moon is not always exactly the same distance away from the Earth and so on. So, you know, at some stages during its orbit, the moon is slightly larger or slightly smaller in terms of its size in the sky. But yeah, I mean, they are extraordinarily close in angular size in the sky.
About half a degree for each of them. So it's the same as if you hold up your thumb at arm's length, you get about half a degree. And there's just no real astronomical or biological reason why that should be the case.
It's a beautiful coincidence.
We're just lucky.
Or is it? Maybe there's a reason behind it. No, it's coincidence. Absolutely. Yeah. But a really good one, because it means that when you get a solar eclipse, you can not just get this incredible darkening of the world, which is freaky and spooky in and of itself, but you can also see, because of the disk of the sun being blotted out, you can see the solar corona, the stuff around the sun, its sort of, you know, outer fringes of its atmosphere that normally is completely hidden to us because the sun's so bright.
Yep.
But if you get rid of that really bright bit, you can see all these amazing things. Have you ever seen a proper solar eclipse?
Yes, I have. It was very exciting. I actually saw one in Cairns in Australia, and I think it was 2012 November. Very lucky. Amazing event.
Yeah, everyone I've spoken to, I've never seen a full one myself. I've seen a partial one, actually here in the UK just a few years ago. But everyone I've spoken to who's seen a full, proper, actual full solar eclipse has said it surpasses all expectation. That you think it's going to be cool, and then it's just so much more. So that's solar eclipses.
Yeah.
So that's excellent. And as I was reading a quote from the famous astronomer Sir Patrick Moore earlier today, who was talking about solar eclipses, and he was saying that, you know, solar eclipses are absolutely extraordinary and mind-boggling. Lunar eclipses, though, have a subtle beauty all of their own. So they're different, aren't they?
They're really lovely, and we shouldn't really view them as the poor cousins to the solar eclipses, because it's really an opportunity to see for yourself the motion of the solar system in action, and at a very nice and calm and smooth pace, which is perhaps a bit more realistic to how the bodies in our solar system move.
Yeah. So, okay, with a lunar eclipse, it's a full moon because the moon is on the opposite side of the sun to us, and so we're getting that full reflectivity back off the face of the moon. So it's a full moon, but it's also in a particular alignment where it passes into the Earth's shadow.
Yeah, and the Earth is a lot bigger than the moon.
So its shadow is much bigger.
Its shadow is huge.
Right.
So lunar eclipses are therefore more common because it's much easier to get the alignment such that you get the moon going into the shadow of the Earth rather than the Earth going into the shadow of the moon.
Right. And it's also why much more of the Earth, even though we don't see a lot of it here in the UK and in Europe, much more of the Earth is going to see this full lunar eclipse than would normally see a full solar eclipse, because that shadow of the Earth is so much bigger.
Yeah. You get about half of the world seeing any particular lunar eclipse.
Now, the other thing about this one is that this is going to be the longest lunar eclipse of the entire 21st century. Have I got that right?
Yes, yeah.
It's going to last
We've got to get some records in there.
Yeah. So, I mean, this is why people are getting interested in this. This is why it's an exciting one for astronomers. It's an exciting one for anyone who's sort of paying attention to the night sky. It's because it's a lunar eclipse, for starters, and that's kind of cool. Get out there and see that. It looks beautiful, and we'll get onto that in a second. But it's also the biggest, the longest lunar eclipse that we're going to have for the entirety of the 21st century.
Yeah.
And there's a couple of reasons for that.
Yeah.
One reason is because the moon's going to be going right through, or pretty much right through, the middle of the Earth's shadow.
Yeah.
Is that right?
So if you imagine the Earth's shadow as a circle, you can go sort of skim the top of the circle and get a very, very short lunar eclipse. Or if you manage to go almost straight through the middle, then you're going to get the longest possible eclipse that you can.
Right, and that's what's happening this time, is that the moon's going to be passing pretty much right through the middle of the shadow.
So our calculations sort of show that the absolute maximum length you can have for a lunar eclipse, if you go straight through the middle like that, and if the moon's orbit is exactly right as well, then the maximum is about an hour and 47 minutes of totality.
Right, and this one's pretty close to that, isn't it?
Pretty close. So we're going to get an hour and 43 minutes.
Right, so it's about as optimal as you can get.
Yeah.
And the other reason it's so long is because the moon is at a particular phase of its orbital cycle where it's actually a bit further away. And, you know, when we're talking about really close moons and really far moons, it's not an enormous distance, or not an enormous difference in how it looks in the night sky, but it is at one of its furthest points in its orbit. And there's actually a name for that, a micro blood moon.
Micro-blood moon.
A micro-blood, because there's got to be a good name for these things. A micro-blood moon. We'll get onto the blood moon bit in a second. But the micro part is because the moon is ever so slightly smaller in the night sky. It's a bit further away. But that means that it's going to take a bit longer to go through the Earth's shadow than if it were at a closer point in its orbit.
So if you remember the supermoon that was at the beginning of the year.
Yes, very exciting, except that it wasn't.
Yeah,
but anyway.
It was a bit overhyped, I think. But the supermoon is basically the moon's really close to us and it's slightly off circular orbit. And therefore the micromoon, I guess as we're calling it now, is slightly further away, for it's slightly smaller. But don't be disappointed. It's really only a few percent in terms of the size you see in the sky.
You're not going to notice it. And it does mean that it lasts a little bit longer, which is a good thing.
Yeah.
Okay, so we've got this really nice long period of time, hour and 43 minutes, that the moon's going to be going through the Earth's shadow. So what do we expect to see then? You know, during a full solar eclipse, things go very, very dark and it's really quite exciting and impressive. This is a much more subtle but nonetheless very beautiful effect. What do we expect to see?
Well, I can give you sort of a play-by-play or blow-by-blow countdown as per the times that we're going to be seeing it, let's say from London. Okay, so these times are going to change a little bit depending on what your local time is. So for us in the UK, we actually are going to be seeing the moon in eclipse when it rises on Friday night. So the actual eclipse begins, the totality begins at 8:30 in the evening, local time. And it will start to rise across the horizon, maybe about 10 to 9, so 8:50, something like that.
And will it be in eclipse at that point?
So it will be already eclipsed at that point. So this is the total part of the eclipse. And this is when we're going to see the red colour of the moon. In fact, it's nothing to do with the moon being red. It's actually the Earth that's causing the colour to change. Because what you'd expect to see is that the Earth's shadow is going to block all the light from the sun that hits the moon. The moon has none of its own light, so it should be black.
Right. It should be instead of a nice bright full moon, it should just be a dark, maybe you'd expect a little bit of light perhaps, but you'd expect to see sort of a fairly dark disk. But that's not what we see at all, is it?
No, we get this beautiful red colour. It's almost a rusty, deep red. And we get
a blood moon, as it's known.
Yeah, exactly. And that's because there is light getting to the surface of the moon and reflecting back at us. And it's coming from the fact that Earth is not a solid blob. We've got an atmosphere at the top, and the light that's coming through the atmosphere and going to the moon is mostly the red light that can travel through the atmosphere.
Right. This is the same reason why sunrises and sunsets are red and purpley coloured. Yeah. It's because as the light's coming through the Earth's atmosphere, the bluer colours are getting scattered. The reason why the sky is blue is because blue light scatters, it bounces off the molecules in the atmosphere much more than the red stuff does. And so the blue stuff gets scattered all around the place, and it makes it look like there's blue light coming from everywhere all around. The sky is blue. But the red stuff tends to pass on through, which is why at sunset and sunrise, the red light coming fairly low on the horizon tends to get to you. All the blue light's already scattered out and gone off to make the sky blue, and you're left with the red stuff that gives you a nice red sunrise. So that red light is going on through to the moon.
Yeah.
Bending down around into the shadow, into the Earth's shadow. Is that what you're saying?
Yes, yeah. So all that red light is going to hit the moon, reflect back at us. And this whole process of the scattering is called Rayleigh scattering. It's a particular type of scattering process. And so it's quite neat to think that actually the same thing that causes the sky to be blue, our sunsets to be red, is causing the moon to be red. And if you were actually standing on the surface of the moon when it went into eclipse, what you would see would be the sun rising and setting over the surface of the Earth.
That would be amazing.
That would be really
Someone's
cool.
got to get up there with a camera one day, surely.
Oh, I hope so.
There's funding in that, isn't there? But I've just been reminded, going back, just a quick connection to exoplanets, because I remember you saying that we can tell a bit about a distant, far-flung exoplanet around a distant star. We can tell a bit about whether or not it's got an atmosphere and what's in that atmosphere by the fact that the light coming from the star behind it is affected by the atmosphere around that planet. And you can see what light gets through and what light doesn't get through that atmosphere in a similar kind of way.
Definitely, yeah. So if we lived on the moon and we weren't sure what the Earth's atmosphere was made of, we could use this technique. So what we would do is we'd take a spectrum of the sun, which is a way to tell what all the chemical elements are coming off the surface of the sun. And then we'd wait for one of these eclipses to happen, and we'd see the sunlight, which is now passing through the Earth's atmosphere to us, and we'd take another spectrum, and we'd compare those two. And the differences, so if there's new chemical elements and so on that we're seeing, or just more of the same ones from the sun, then we can say, well, that's come from the atmosphere rather than coming from the sun.
So we know what's in there because we can see how it's affected the light on the way through.
Yeah.
Very cool. Yeah, that just rang a little bell in my mind.
It's a good point.
That's all coming through. So, but we got a bit distracted there for a second because you were giving a play-by-play. So we got as far as moon's going to come up and it's already going to be in full eclipse when it rises. So it'll be on that sort of pinky, browny red.
Yeah, so it's kind of like you're holding up a piece of red filter and you can see the same surface features of the moon. They'll just be, the moon will be a bit dimmer and it will be this red colour.
And it'll be full. So it'll be big round circular moon, but it'll be that reddy colour.
Yeah. And then the total eclipse finishes at about 9:20, 9:21 in the evening. Now, it's going to be quite tricky to see the totality between this 8:50 p.m. and 9:21 p.m. If you want to go see it in the UK, you really have to go somewhere where you can see the horizon in the southeast, because it's only going to be a few degrees above the horizon.
Right, so it'll be over reasonably quickly.
Yeah, well, it'll be just very, very close to the horizon. So if you've got, hills or trees and things like that in the way, it could be very, very difficult to spot.
Of course, because, I sort of forget this. I'm still not quite used to, after a few years in this country, I'm not quite used to being actually so far away from the equator. And, of course, when the moon rises, it's actually doing it at quite an angle, isn't it?
Yeah.
Same as the sun, of course,
exactly,
which is why... sunrise and sunset, dusk and dawn take so long this time of year. It's why the nights are so long and the mornings start out so early, is because everything's coming up at such an extreme angle. And so it's going to take the moon quite a long time to actually rise up above the horizon.
Yeah. So if you're looking to see it in totality, do find a place where you can see the horizon clearly to the southeast.
Cool. Yeah. Okay, so the full eclipse will be over by
at
roughly
9:21.
9:21.
Yeah. But then we'll get to see the partial eclipse, because what's going to happen then is the moon is starting to move out of the Earth's shadow. And what we'll see is that we'll start to see just a tiny little slither of the moon, as if it was a new moon. And at that point, the contrast becomes pretty strong. So we can't really see the red anymore, because you're just getting so much light from that tiny little slither, as we normally do from a really bright full moon. It's just too hard to see the red anymore. And then that little slither will grow and grow and grow and grow. So it'll kind of be like seeing all the phases of the moon stacked up next to each other.
Wow. That'll be cool.
Very, very
That'll be cool. I'm looking forward to seeing some really good photography coming out of this one. Let's hope for some clear skies. Yeah. We've been pretty lucky in the UK over the last little while, which is not the sort of thing that you tend to say in the UK. Gee, the weather's been good, but it has. So fingers crossed for Friday night.
So that sort of slow moving out of the shadow, therefore the slither of the moon growing larger and larger and larger, will carry on until about 12:30. So
right.
12:28.
Right.
In the morning.
So if you want to see the full totality of the lunar eclipse, then you've got to try reasonably hard. You've got to get somewhere where you've got a good, clear view of the uninterrupted horizon to see the moon coming up. But then you've got at least a few good hours for that partial eclipse as it moves its way out of the shadow of the Earth.
So even if you're getting patches of cloud coming and going, it's worth going out and having a look in the breaks between those clouds, because you will see this sort of changing shape of the moon in between the little snippets that you get.
Very cool. Okay, looking forward to that. Now, the moon's not the only thing up at the moment. The night sky is kind of interesting. And the reason I say that is because when I was Googling this earlier today, to just sort of make sure that I knew what I was talking about, at least a little bit. Well, first of all, I found the Sunday Express, which is a quality newspaper here in the UK. I'm sure everyone will agree. And the headline from just a couple of days ago was Blood Moon 2018, Will the World End with the July 27 total lunar eclipse? Now, there is a law of headlines. It's called Betteridge's law. And it says that if you have a headline in a newspaper or an online outlet, if there's a question in that headline, then the answer is obviously no. And so the question, will the world end with the total lunar eclipse? No. No, it's not going to. But the reason that that's being asked at all is because any time something like this comes along, a solar eclipse, a lunar eclipse, planets getting into the right or the wrong place in the sky, people are going to come out of the woodwork and say, but it's a portent of doom and the fire and brimstone will rain down upon us and there will be locusts and plagues of frogs and things. And so some people are coming out and saying, blood moon, even if it's a micro blood moon's going to end the world. It's not. I did also come across a website, an astrology website, which made the following statement. The lunar eclipse in July 2018 is mainly influenced by Mars, making this an emotionally challenging eclipse. So, I mean, I think, Emily, you're going to have to prepare yourself.
Yeah. I think for me personally, the most emotionally challenging aspect might be if there's clouds.
Well, look, and here's what you need to keep under control. This astrology site goes on to say Mars's anger and frustration could easily turn to reckless actions because of a harsh aspect to Uranus. So I want you to be careful this Friday. If there are clouds out there, just take a deep breath, Just count to 10. It's going to be okay. Don't let Mars and Uranus get out of control. All right? Now, we joke. Yes, we joke. Yes. But of course, astrology, look, taking the best possible reading of it that you possibly can, there are some interesting things happening. And those interesting things are, we have a micro blood moon, we have a lunar eclipse, and it's going to look cool.
Yeah, those things are definitely real.
Yeah, those are real. And we also have some planets in the night sky, which, because of the fact that a full moon is going to be somewhat diminished by going into a shadow, those planets are going to be a bit more prominent.
Yeah. Look, we go on all the time about how important it is to go find a dark space to go out and look at the night sky.
And we're not going to stop
it.
doing that, folks, so get used to it.
And during this lovely Northern Hemisphere summer, I have to say, words I think I'd never thought I'd say about the UK.
I know. It's crazy, isn't it?
But it's just a perfect time to go stargazing because it's actually lovely and warm. You can lie out in the cool night air and enjoy some of the most wonderful things that go on in our skies, like the eclipse. We've also got Venus up in the sky at the moment. We've got Mars up in the sky. We've got Jupiter. So those are great things to get out and spot. And even if you can get a pair of binoculars and have a look around at Jupiter, if you're very, very lucky, you might be able to spot some of the moons of Jupiter.
We'll put a bit of a map of the sky showing the positions of some of these things, a star chart, in the show notes this week, just so that you've got the best chance you possibly can, and with that information about the lunar eclipse as well, so that you've got the best chance. I mean, I guess the only downside of the really long, lovely summer evenings that we're getting here is that it takes so long to get properly dark that you've got to wait up really late to actually see the stars in this country.
Yep. And the astronomers are a little bit annoyed about that.
So, we joke about the astrologers and the proponents of the end of the world theory who never seem to be concerned about the fact that the last time that they said it was going to be the end of the world, it wasn't. Definitely this time. Anyway, we'll push those aside. It's not a new phenomenon for people to come out and say all of these astronomical phenomena are very important and have significance to our human lives. We've been looking at these things for millennia, and they have significance to us as human beings.
Definitely, yeah. In fact, lots of ancient cultures had their own stories and interpretations of what was going on. A couple of my favourites, as I was doing a bit of reading around, in ancient Egypt, a lunar eclipse was interpreted as a sow swallowing the moon.
A sow, as in female pig.
Yep.
Okay, specific, but I like it.
Yeah, and this is kind of also one of the reasons why it's red.
No,
somehow.
You lost me.
Insides of sows in the sky.
Sure. I'll buy that.
Yep. The Mayan and Incan cultures in the ancient world also had a jaguar eating the moon. So maybe it just depends on what your local fauna is like.
Yeah, I mean, I guess that makes sense. You write about what you know, as they say. Yeah. I kind of like the idea of the jaguar, though.
I guess the eating comes from the fact that you get this kind of curved surface, like curved shadow of the Earth falling on the moon. And
it's not something that happens like that. It's a slow, gradual chomping away at your full moon. Yeah, I like that idea.
So it could be like a little bit of a bite out of the moon.
Yeah. I'm on board with the Incans. I like the jaguar. I think go with that.
Yeah. And in fact, actually, this curved shadow that you can see on the surface of the moon, the ancient Greeks used this to prove that the Earth was round.
Ah, okay.
Very clever.
Although arguably round, but not necessarily spherical. A flat circular Earth would give you a circular shadow as well.
Oh dear. Let's not go down that road.
I'm just saying, okay? It doesn't prove anything, Emily.
But the Greeks knew that it was a sphere.
Yeah.
They're clever.
Maybe we'll do that another day. That could be an entire other episode, is how do we know that our astronomical theories are right? We can do that another time.
Sounds fun. Yeah, so there's lots of really interesting things. And the great thing about eclipses, both solar and lunar, is that there are only a few every year. So there's maybe up to between 1 and 4, let's say, lunar eclipses in a year, maybe 1 solar eclipse in a year.
Yeah, I mean, I was reading on that astrological, I didn't read a lot, don't worry, but on that astrological website.
You've changed.
I have, I know, but it's so compelling. It was talking about how this lunar eclipse was going to have that much more impact on our earthly lives because of the recent partial solar eclipse. And I thought, hang on, what? And I had to go and look it up. And about a month or so ago, back in early June, I think, there was a partial solar eclipse, as in very partial, as in just sort of clipped the top off the sun. But I thought, I don't remember hearing about this anywhere. So I went and looked it up, and I had to search quite hard to find it. And I eventually found a map that showed where this partial solar eclipse was visible back in June this year. And it was pretty much the entire part of the Antarctic Ocean, south of Australia and north of Antarctica. So I think a very, very small part of the bottom of Tasmania might have seen it, and then a lot of people floating adrift in the ocean on their way to the South Pole. And that's it. No one else on the entire planet had a chance of seeing this. But apparently it's significant to our astrological forecast.
Wow.
So there you are.
Indeed.
But as you were saying, there's only these things don't come along all the time.
No, and we do have a very good records of it. Well, we can work out and calculate back, basically, when exactly, all throughout history, when exactly there were solar and lunar eclipses. And then, fortunately, lots of historians in the both ancient and even more recent histories talked about things that happened when solar and lunar eclipses happened. There were important battles, or an important king died, or these kind of things. And what's amazing is that we can then put a very, very precise date. We can say that on this exact day, and this exact month, and this exact year, even at this exact hour, is when this particular event took place.
Wow. And that's a really nice test as well of our astronomical, careful Chris, our astronomical models.
Yes.
It's not just as simple as the moon going around the Earth on a circular orbit and getting in the way of the sun every once in a while. It's somewhat more complicated than that. The orbits are a bit more complicated. The Earth's orbit around the sun is more complicated. There are other things getting in the way. And so these are complicated models. So to be able to wind the clock back hundreds of years to an exact hour and day and year and go, does that agree with the retro prediction of our model? That's a really nice test.
Yeah. You've got to trust the historians that they're not just sort of being a bit gentle with the truth as well, which sometimes they were. But yeah, most of the time, actually, these dates all line up, and it's really quite exciting.
Because you can do that sort of thing with things like comets and stuff as well, can't you? That things like Halley's Comet, very famously coming around every, 87 years or something.
Yeah.
But very prominent in the sky when it does come through.
Yeah.
Is written into all sorts of histories and as portents of great changes in historical episodes.
And they last for a few months, so quite a lot of important events can happen in those few months.
Yeah, you can tie a lot to a comet, I think. Yeah.
And even supernovae, we do have ancient history, ancient Chinese astronomers recorded the 1056 as Crab Nebula, which is, that's the nebula that we see now, was originally produced by a supernova 1,000 years ago.
Which would have been incredibly bright in the sky.
Very bright.
Not sort of sun bright, but definitely, hang on, that wasn't there. The other day, last time I looked at the sky, that big bright thing was not there. That would be a bit disconcerting, I think, to someone who doesn't know what a supernova is.
Yeah. New stars appearing. What does that mean? So, we always go on about this is going to be the longest eclipse, say, in the 21st century. It's going to be the only time you're going to have the opportunity to see this particular event for another 150 to 3,000, 4 million years, whatever it might be. There's quite a lot of dramatization that goes on with this.
Yes, don't miss this one, kids. But, in all seriousness, okay, we do know that this is going to be the longest lunar eclipse in the 21st century, but it's not the only.
Not by any means, no.
So how long would we have to wait to see the next one?
Well, okay, so if you're in the Americas, both North and South, actually you don't have too long to wait. The next one is in January 2019.
Okay, so the Americans are being left out this time around, but they don't have that long to wait.
No. So lunar eclipses, as I say, you get a few a year. The interesting thing is you might see a little bit of that one in the UK here, but you'd have to get up at about 5 o'clock in the morning in January, which is not usually advised.
Nah, it's not worth it.
So I had a quick look through all the dates, and there's quite a few upcoming dates where you can see lunar eclipses over the next kind of 10 years or so. What was pretty astounding is that it seems like the UK is missing out on most of them.
What? I blame Brexit.
So if we do get, we might get a little bit of some right on the edges, a bit like this one, but to get a nice full total eclipse from start to finish, in the UK, you're going to have to wait until 2029.
It's like 11 years away.
Yeah.
That's hardly fair.
I know. It's just weird coincidence or weird orbits properties of the moon that means that we're going to miss out for a while.
Is there someone we can write to? The International Astronomers Union or something? And just,
I think
get on the case of this.
That's a good idea.
It's just not fair.
But if it helps, then you've got solar eclipses to keep you occupied as well.
Yeah, okay. So they're not as common, are they?
They're not quite as common. We get about one a year, but that's it can be a partial solar eclipse, or it can be a total, or it can be what we call an annular solar eclipse.
What's an annular? I haven't heard of those.
Okay, so that's when the moon's not quite big enough to cover the whole sun.
Yeah, as we were saying before, it's the moon is almost exactly the same size as the sun, but the moon's orbit isn't circular. Sometimes it's a bit further away, sometimes it's a bit closer, and so this is where the moon passes in front of the sun, but isn't big enough in the sky to actually block it all out.
No.
Right.
So you get a little bit of ring around.
Right, which is what annular means. Annular means a ring around the outside. Wow, that must look cool.
Yeah, but you don't kind of get all the really cool stuff that happens with the total.
Right.
So they're sort of second best in terms of solar eclipses. But so there's a few of those. But if you want to, so there's very, very narrow tracks that these solar eclipses cause on the surface of the Earth, the places where you can go see them. There's not half the world can see a solar eclipse.
Because the moon's shadow is so much smaller.
Because it's tiny, tiny shadow. But we're going to have a nice partial eclipse in June 2021. Mm-hmm. And then, at least for the UK, to get a good total solar eclipse, we're going to have to wait till 2090.
2090? That's ages away.
That's a very long time away.
I mean, that's just bad planning.
So a much better option is to go and look up where the next set of solar eclipses are going to be and travel the world.
Well, okay, if we have to.
Yeah.
And that brings us to the end of another episode of Syzygy. As always, we really are interested in hearing what you think. If you want to get in touch with us, there's a number of different ways you can do so. And when you do, submit a question, send us your thoughts. We've had an entire episode devoted to a listener question in the past. If you send us a good question, we might do so again. But regardless, something on your mind, let us know. There are a number of ways you can do that. First of all, you could go to our website, syzygy.fm. Click on the contact link and there's a form in there that you can get in touch. Or go through social media. Emily, you're a social media queen. How do I do that?
Good old Twitter. So we're at SyzygyPod on Twitter. And of course, we've got our Facebook as well.
Yes, indeed.
So if you just look up Syzygy on Facebook, then you can come on over and like us. We'll put up some nice pictures of the eclipse after the fact. But if you take some pictures of the lunar eclipse, please do let us know.
Yeah, send them our way.
Yeah.
Send them our way. That would be brilliant. Send us a little story of how you've viewed this thing, where you were, and the pictures you took, and we'll feature them on Facebook and maybe chat about them in the next podcast.
Yeah, that'd be cool.
That'd be great. The other way that you can tune into this podcast is the somewhat more visible way, which is a bit odd for an audio podcast, but we are on YouTube. And the reason we do that is because, well, that's where the kids today hang out, apparently, but also because we like to put up in our show notes pictures of astronomical things that we come across and links and so on. And YouTube's a nice way to do that. So if you want to make sure that you get those aspects, either get yourself a podcast player on your phone of choice, which can do chapter markers and chapter images, or head on over to YouTube and check out the podcasts over there.
Just remember, astronomy is so beautiful and you don't want to miss out on some of those pictures.
That's right. And I mean, we have a lot of fun tracking down some of these great pictures, so it's worth checking them out, particularly when there's something like a micro blood moon. So we're going to do our best to get this episode out for Friday first thing, so that you've got a chance to listen to this and then get outside of your houses and go and look over to the east. Southeast. And check out that blood moon. So with any luck, we'll see a few pictures coming through next time. But until next time, that's all from us. Yep. Thanks very much for listening, and we'll catch you next time.
We'll see you after the end of the world.
Bye-bye.